Welcome to lecture series of engineering drawing and graphics for engineers. In this series of tutorials, we are discussing the different topics of engineering drawing and graphics theory course for different disciplines of engineering. So in this third lecture, lecture number 3 of part A, we will discuss the basic geometrical construction. Okay, remember, before going into the complex engineering drawing, before going into the drawing of different or complex objects or complex structure, first we will have to know some basic geometrical construction. Okay, for example, if someone want to learn a language, so first we'll understand the alphabet of that language. And when you understand the alphabet of that language, then you will be able to form the words from that alphabet. Okay, and then you will be able to form the different sentence from the words. So first you have to understand the alphabets, then you will have to understand the words, then you will be able to make the sentences of a specific language. So similarly, first we will have to learn the alphabet of the engineering drawing, then we will learn the different words of the engineering drawing, then we will be able to make the sentences of the engineering drawing, mean the complex drawing of the different objects. Okay, so see, the basics and the basic alphabet of the engineering drawing is, the first one is the point. Okay, point is the basic alphabet, the first alphabet of the engineering drawing. Then when the different and infinite points are combined, then we get what? Then we get line. And after the combination of line, we can draw the different geometrical shapes. So these are called the alphabets of the engineering drawing. See, first we have to know about the point, then the combination of the infinite point make line, and then the combination of 2, 3, 4 or more line form the different shapes of the different object. Okay, so point is a geometry. A point in geometry is a location. It has no size. Okay, for example, this is a point. So in reality, in actuality, it has no size. For example, no length, no width, no depth. Okay, a point is just represented by a dot. Okay, mean that is just the representation of point, and the standard definition of point is that it has no size, no length, no width, and no thickness or no depth. Okay, then we have the line. So line is a set of points that extends infinitely in two directions. See, for example, if we have a line in this frame, so it means that the line can be extended in both direction infinitely. If we have a line in this form, it means that it is a line having a fixed length. If we have a line in this form, it means that it can be expanded in one direction. If it is in this form, it means that it can be extended in this left direction. So this is the definition of the line. So line is a set of points that extends infinitely in two directions, and it has one dimension, mean only we will have the length of the line. Only we have the length, mean we have one dimension, and the line can be extended in two directions. Okay, now when the different when the 2 or 3 lines are combined, then we can get the different shapes of the geometry. For example, if we combine, for example, 3 lines, so what we will get? We will get triangle. And for example, if we combine 4 lines, what we will get? We will get quadrilaterals. And when we combine more than 4 or 5 lines, what we will get? We will get different shapes of the polygons. Okay, so the basic element or the basic entity of the drawing is point, then we have line, then the combination of different line makes the different shapes of the geometry. Okay, so in this lecture, basically we will be able that how we will draw the basic geometrical objects. Okay, so that is also called the plane geometry. See, we have a branch of the mathematics, a branch of the engineering, which is called the plane geometry, in which we draw the different shapes of the different drawing objects. Okay, so first in plane geometry, first we have the point. okay, then we have the line, and when we combine two or more line, then we can obtain the triangles. Okay, so in triangles then we have different form of the triangles, like right angle triangle, equilateral triangle, isosceles triangle, obtuse angle triangle, acute angle triangle. Okay, but it will have only 3 sides. After that, when we have 4 sides, then it is called quadrilaterals, or that is called quadriangles. Quadrilaterals are quadriangles. Okay, then the quadrilaterals or quadriangles will be of 2 types. One is called the regular quadrilateral, second one is called the irregular quadrilateral. Okay, regular quadrilateral mean when it is properly drawn. For example, square an example of regular quadrilateral. Similarly, rectangle is an example of regular quadrilateral. Okay, now any other shape of 4 sides which are not square or rectangle, that will be called the irregular quadrilateral. Also, when the sides are more than 4, then it is generally that is called polygon, or that is called polyangles. Okay, so again, that polygons or polyangles will be either regular or it will be irregular. When all the sides of the polygons are same, then it is called regular polygon, and when all the sides of polygons are not same, then it is called the irregular polygons. Okay, so this is just a background of the plane geometry, that we have point, line, triangle, quadrilaterals, and then we have the polygons. And quadrilateral and polygon, either that will be the regular or irregular. Okay, now in this lecture number 3, we will solve the different problems of the book Engineering Drawing by N.D. Butt, 53rd edition. And in this first part, we will solve the problems from 5.1 to 5.10. And in this basic geometrical construction, actually we are dealing with the bisection of line, or to draw the parallel line, to divide a line in a given number, to divide a circle, to bisect an angle, to trisect an angle. Okay, to find the center of an arc, to construct different types of curves, to draw the triangles, to construct the squares, to construct the regular polygons, to inscribe the circles. Okay, so we will just deals with different shapes of the plane geometry, that how it will be done. And remember, once you understand the construction of these basic objects, then you will be able to draw the complex drawing of different objects. Okay, so problem 5.1, to bisect a given line. For example, if a line is given of the given length, for example, that is AB line which is given having length, for example, having length AB. Okay, the length of the line is given. Now the requirement is that we have to bisect this line into 2 equal parts. Okay, so open a compass greater than half of the length of this AB. Okay, open a compass greater than the length of the half of the length of this AB, and with center A, mark an arc here and mark an arc here. Now with the same radius and center B, mark an arc here and mark an arc here. Okay, so for example, this is point C, and for example, this is point D. Okay, now just join the point C and D with each other. Okay, suppose it intersect this AB line at point E. Okay, so now this AE will be equal to EB, and that will be equal to half of AB. Okay, so see, this is the we can say this is the required bisection of the given line. Okay, now problem 5.2, to bisect a given straight arc. Suppose an arc is given. Okay, for example, that is the given arc, some portion of the circle. Now the requirement is that we have to divide this arc into 2 parts. We have to bisect this arcs. Okay, so now see, let AB be the given arc having a center O. Suppose the center is given, that this arc is drawn from this center which is O. Okay, now with the center A in any convenient radius, mark an arc here and mark an arc here. Similarly, then with center B, okay, and with the same radius, mark an arc here and mark an arc here. Okay, suppose that is point C and this is point D. Now join this point C and D, okay, point C and D, and suppose this is the point E. So AE will be equal to EB, and that will be half of the arc AB. Okay, so this is the bisection of AB arc. Now to draw a perpendicular to a given line from a point within it. See, again we have different cases. Suppose this is the given line. Suppose this is the given AB line. Now for example, a point is given on the line, that is the point P. Okay, AB is a given line and P is the given point. Now we have to draw a perpendicular to this AB line which will pass from P point. Now remember, when the point is near to the middle, see, the point is near to the middle, okay, then with center P and any radius, just take a compass and with any radius, with center P, mark here an arc and mark here an arc. Okay, suppose this is point C and this is point D. Okay, now with any radius greater than this radius and points with and at center C, mark an arc here. Now with the same radius and point D, mark an arc here. Mean with center D, place a compass here and mark an arc. Okay, and place a compass here at C and mark an arc. Suppose that is point O. Now join this O with P. So this will be the required perpendicular to the given line AB. Okay. Second method is, suppose this is the given line AB. Okay. And suppose this is the point at which we have to draw the perpendicular to the given AB line. Okay. Now at any point take any point O and with radius OP, okay, assume any point, any center point, and with radius OP just draw an arc. Okay, with center O and radius equal to OP, draw an arc. Okay, now see, draw an arc like this one, and see that arc will intersect the line AB at point C. Now join C with O and extend it. So it will intersect the arc at point Q. Now join this Q with P, which will be the required perpendicular. Okay, see, let me revise it. Suppose AB is the given line. Okay, here we have this point, this is the P point at which we have to draw the perpendicular. Assume any center point O and with any radius draw an arc. Okay, so this arc will intersect the AB line at C. Now join C with O and extend it. Okay, so it will intersect the arc at point Q. Now join this point Q with P, which will be the required perpendicular. Okay. The third method is, suppose this is the AB given line. Okay, for example, this is the point P at which we have to draw the perpendicular. Now with center P and any radius, draw an arc. Okay, so now with center C and with that same radius, mark two arcs here. Suppose that is D, and here suppose that is E. Now with center D and E, mark here two arcs, join it with point P, which will be the required perpendicular. Okay. Problem 5.4, to draw a perpendicular to a given line from a point outside it. See, in the previous problem, the point was on the line. Now here suppose we have the line AB, okay, and for example the point is outside. Here we have the point P. Now we have to draw a perpendicular to line AB which will pass from point P. Okay, so the procedure is, with center P and any radius, draw an arc which will intersect AB at 2 points CD. Mean, with center P and any radius, draw an arc which will intersect AB at 2 points C and D. Okay, now with any radius greater than half of the CD, and from center D mark here an arc, and with center C mark here an arc. Okay, now join these 2 points. So this line, this PE line, will be perpendicular to AB. So we have drawn a line perpendicular to AB which is passing from a point outside the line. Okay, similarly we have another method. Suppose this AB is the given line. For example, here we have the point P. Now we have to draw a line perpendicular to AB passing from P. Okay, so with center A and radius equal to AP, draw an arc. Okay, draw an arc. Now suppose this is point C. Okay, now with center C and radius equal to CP, draw another arc which will intersect the previous arc at point D. Okay, now join P and D. So this, suppose this is point Q. So QP will be perpendicular to AB. Clear? Now we have to draw perpendicular to a given line from a point outside it when the point is near the center. Okay, suppose we have a given line AB and the point P is given. Now we have to draw a perpendicular to this AB line which will pass from point P. Okay, so using a compass, with P is center, draw an arc of any radius. Okay, with center P and any radius, draw an arc, so which will intersect, which will cut the line AB at 2 points C and D. Okay, now with center C and D, mark the arcs. See, with center C mark 2 arcs, and with center D marks an arcs. Okay, now join this P with the intersection of the 2 arcs and extend it towards the AB line. So this QE will be the required perpendicular to AB, which is passing from the given point which is outside from the line. Okay, see, that will be exactly perpendicular. Now to draw a line through a given point parallel to a given straight line. See, suppose we have a straight line AB. Now we have to draw a line which will be parallel to this line, and suppose passing from this point P. The point is outside the line. So now we have to draw here a line which will be parallel to AB and passing from this P point. Okay, so with center P and any radius, draw an arc CD. With center P and any radius, draw an arc CD which will intersect AB at point E. Okay, now with center E and the same radius at which you have drawn the CD arc, with center E and same radius, mark here an arc. Okay, suppose that is F. Now open a compass up a length equal to FP. Open a compass up a length equal to FP, and with center E mark here an arc. Okay, now join this point with this line with this point. So see that PQ line will be parallel to AB line and passing from the given point. Okay, you can revise the video, you can repeat the video to understand the process. Problem 5.7, to draw a line parallel and at a given distance from a given straight line. See, in the previous problem a line was given and a point was given, and we have to draw a line parallel to this line passing from the point. Now here we have, suppose AB line is given, and for example the distance is given, that for example we have to draw another line parallel to AB at 10 centimeter. Okay, that to draw a line at 10 centimeter and parallel to AB, mean at 10 centimeter distance you have to draw a line. Okay, so just take any 2 points on this line. Take any 2 points. Suppose this is point P and suppose this is point Q. Take any 2 points on the given line. Okay, and with center P and the given radius at which you have to draw the parallel line. So with center P and for example at 10 centimeter or X centimeter, draw here an arc. Now with center Q and with the same that given distance, mark here an arc. Okay, now just draw a line touching these 2 arcs. So it will be the parallel line to AB and at a given distance. Okay, now to divide a given straight line into any number of equal parts. This is most important. Also we have used it in the previous lecture, scales construction. Suppose a line AB is given. Now you have to divide it into any number of equal part. We have to divide this line into any number of equal part. Okay, so just draw the given line. Okay, draw another line AC just less than at 30 degree. Draw AC line less than 30 degree. Now with the help of divider, just mark, for example we have to divide this AB line into 7 equal parts. So just draw AC line at less than 30 degree angle. Now with the help of divider, mark here 7 equal parts of any length. Remember, of any length. Suppose you are dividing this AB line into 7 parts, so just take 7 equal division on this AC line of any length. Okay, mark them. Suppose 1 dash, 2 dash, 3, 4, 5, 6, 7. We are dividing this line into 7 parts, so we have taken 7 division. If you are dividing this line into 10 parts, just take here 10 division. Okay, of any number in which you are interested to divide the given line. Now join the last point with B. Join 7 point with B. Okay, join 7 point with B and draw parallel line to that 7B line from the rest of the point. See, join 7 point with B, join point 7 with B, then from 6 draw parallel line to 7B, from 5 draw parallel line to 6 line, from 4 draw parallel line to 5. Okay, just draw the parallel lines and see the given line is divided into 7 equal parts. Okay, this is the division of a straight line into any number of equal parts. Okay, now suppose to divide a given line into unequal part. The previous one was the division of the line into equal part, and this is the division of a line into unequal part. Suppose we have a line AB and for example we have to divide it into some unequal part. So just draw here a perpendicular line and draw here a perpendicular line. Okay, just make the a rectangle join, suppose this is point D and this is C. Now just join D with B, okay, and C with A. Now from this point, suppose from this E point, draw a perpendicular to AB, okay. So suppose this is F, so AF will be equal to FB, and this will be half of AB, half of AB. See, this will be how much? This will be, we can say that half of AB. Now join D with F, join D with F. Now suppose this is point G. Now from point G, draw a perpendicular to AF, okay. Suppose this is H. Now this AH, that will be, this AH will be 1/3 of AB. Remember, AF was half of AB. This AH will be 1/3 of that AB. Okay. Now join D with H. D with H. Suppose this is point I. Now from I, draw a perpendicular. Suppose this is J. So this AJ will be 1/4 of AB. So see, the line is first divided into half, then divided, then taken 1/3 portion, then we have taken 1/4 portion. Now join D with J. So suppose this is point K, draw perpendicular from K to here. Suppose that is L. Now AL will be 1/5 of AB. Okay, so this is the division of a straight line into unequal part. Okay, you people just make the practice of these things and revise the video again and again. You will properly understand it. Okay. Next question, to divide a circle of a given radius into n equal parts. Suppose the circle is given. So obviously if the circle is given, its radius will be given, and now we have to divide the given circle into equal parts. So suppose if radius is given, so just draw a circle of the given radius, okay, and see, that will be the full circle. And when you just draw a line passing from the center of the circle, so the circle will be divided into two parts. Okay, now when you draw another line perpendicular to this previous diameter, so the circle will be divided into four parts. Okay, so this is the division of the circle into equal parts, two parts, four parts. Now suppose you are dividing furtherly this circle into a number of parts. So see, just draw a circle of the given radius, okay, and mark the two diameter perpendicular to each other. Okay, suppose this AB diameter and CD diameter, these two are perpendicular to each other. So the circle is divided into four equal parts. Okay, now with center A, see, with center A and equal to the radius of the circle, mark here a point, mark here a point. Okay, now with center C and the same radius, mark here a point and mark here a point. With center B and that radius, mark here a point and mark here a point. With center D and that same radius, mark here a point and mark here a point. When you join it with the center, so the circle is divided into 12 equal parts. The circle is divided into 12 equal parts. So again, this is a graphical method that how a circle will be divided into 12 equal parts. Okay, see, just draw the circle of the given radius, draw the two diameters perpendicular to each other. With center A, draw the two arcs. Now with center C, draw the two arcs here and here. With center B, draw two arcs. With center D, draw two arcs. So you will get such type of shapes. See, now you can join these 1, 2, 3, 4, 5, 6, 7, 8 points, and the circle will be divided into 12 equal parts. Okay, So this was the first part of lecture number 3. If you have any question, comment and concern, you can ask. The lecture is continued, and in other parts of this lecture we will discuss some other geometrical construction. Thank you.